Hi, and welcome to another short interview about the silicon bring-up process and some of the successful results we're seeing from chipIgnite. And today I'm talking with Dinesh. How are you doing, Dinesh?
Yeah, I'm doing good.
We spoke about a year ago, I think, about your Riscduino project. So I'll link that interview up in the corner of the video there. But for people who don't know about Riscduino, maybe you could give us a little recap.
So I'm just flashed the Riscduino basic architecture. So this Riscduino I started from nearly from MPW2 onward, where I started with a basic RISC-V core. Then I was looking for an SoC model which I can demonstrate my engineering experience. So then I was looking for an idea. Then I picked a Arduino. So I like the Arduino concept. Then I thought, this is a good opportunity to put a RISC-V core, which is a pin compatible to an Arduino platform. So from there, I started and trying to integrate the basic IPs required for this SoC. And so here, basic block diagram is if you see it, I have a one RISC-V core, which is 32-bit RISC-V core, and I have a cache, inbuilt cache, instruction cache, and data cache, and tightly coupled data memory. Apart from this, it has a basic infrastructure IP like two UARTs are there, one I2C master is there, and USB 1.1 host, and serial SPI. And there are additional features like PWM and timers and the LED driver. So these are the basic
Yeah,
components what I have.
nice.
And to bring up the design, I kept three options. One is the Caravelle wishbone interface, through that user can come through the wishbone interface and configure the IPs and bring up the design. So that's the one way of bringing up. So if Caravelle doesn't work, so one more option I given was the UART master. So through the UART master also, user can come in and can wake up their design, and we can test the SoC. Third option is a slave SPI slave, which is typically standard Arduino chips supports SPI slave type. So through that interface also you can come in here and you can configure the SoC. So
So lots of backups and redundancy.
yes, as a designer, typically we keep three way of booting. That is the basic. We keep it. One fails, next fails, next. So typically that is the basic concept. Anyone from SOC background, they know SOC is there to fail first round. So we try
Yeah.
to keep as important. At least the boot up is a very important part, and typically we try to keep up as easy options as possible, as much as possible.
Okay. One thing that I see missing here that we did touch on the last time we spoke was the analog side of things. Have you made any progress with the A to D or D to A that comes with the Arduino?
Currently, I have some designers who are working. They are working on the EDC, but it is not yet integrated into any of my current tapings. So I can only plan for the next tapings. Currently, I'm
Maybe we'll touch on that at the end then when we talk about next steps.
yes.
Okay. So you've been one of the people that has been sending off many designs. I think you've probably. I don't think you submitted on MPW1, but you have submitted for the rest of them. Um, how many of the chips have you got back so far?
So if you see the total number of tapings I done, I'm not
Oh, nice.
taping MPW2. MPW2 only I started my first taping with the basic
Hmm.
RISC core, which I am. We already received this MPW2, and followed by MPW3. I done two tapings. One with which this is the first version of Arduino compatible as SoC core, which I attempted here. And one more I done is a MBase controller. So this is the MPW3. And in MPW4, which is one more improved version of the same Riscduino, and it's a LBIST controller I added there. And in MPW5, two different version of Riscduino I done. One with a single core and other is a dual core. And one once again I think LBIST controller improved version has done in the MPW5. So if you see the series wise, typically I try to wherever chance is there, I try to push in three Riscduino tape ins. One is a single core, other is a dual core, and a quad core. So that's what I typically attempted the improved version.
Is the Q a quad core?
Q for quad core, D for dual core,
Okay,
S for single core.
single core. Okay, nice. Okay, and then you're bumping the numbers on every tape out.
Yes. So in around MPW6 time, I had a chance to do a one chipIgnite tapings. So currently, this one is the what currently I'm bringing up, and
Great.
because the why I have tried is in this only the Caravelle issue is fixed, so I don't want to try it here because the whatever the CI06 compatible to my MPW6 equivalent design. So that gives me more confidence that once
Yeah,
MPW6 came in, so they are also going to behave similar to this chipIgnite 06.
yeah. So for anyone that's watching that wasn't aware that there were problems with MPW 1, 2, 3, 4, and 5 on the I/O configuration. So that meant that you could have a working design, but find it difficult to configure all the pins how you needed them. But from MPW 6 onwards and this CI0622 that you got down there at the bottom, all that stuff is being fixed. So you said that this is the one that you're bringing up at the moment. Maybe you can give us an update on how that is working and any problems you found, what were your successes, this kind of thing.
Yes. Uh, so that's what the biggest typical problem is when you get a chip. So since these are untested chip, to find out is it a design issue or a chip issue, that itself is a one big challenge typically. So when I
Mm-hmm.
started the chip, first thing I done is I put it in the breadboard and put the whatever required IPs in the breadboard and try to see is it passes any test, basic test. So then I try to find out any out of 10 whatever that add-on cards they given, is it any place I see at least basic things comes up. So interestingly, I saw even the full feature not worked. First two three chips are showing a basic function worked. Like I'm able to configure my quad SPA and I'm able to wake up a recipe with the external booting, not with the internal SRAM. That is the where I started. And what I noticed is the chip was showing some hold, and it was working fine at 1.6 volts, but not at 1.8 volts. So that is the first observation I had. And other observation was these SRAMs, whatever is there in the on chip, they need at least 1.7 to work cleanly. Means otherwise it was start giving a bit errors. So because of that challenge, nearly I need to work in a external boot mode. The external SRAM both I need to pick externally. That's the way I started. Even though the boot actions are slow, but at least I thought let me start with that function. And that's the where the initial whatever the bring ups I done. But now, as I see, started checking the multiple chips, I noticed that some of the SRAMs are working at 1.6 also, which enabled me to wake up the cache access. So, which is I can see it is doing my near at least somewhat similar as the Arduino chip with maybe 3x, 4x slower maybe, but at least the activities, the performance, because I feel like it is just 4x small, lower than the Arduino 3 to 8. That looks somewhat interesting. And also, currently I'm running just with 10 megahertz system clock, so I have some more option to increase it and see whether I can match the Arduino capabilities.
Do you know what the problem is with the memory?
So I think that the first problem is that interface timing. They are not taken care for the both. Their lips are not clean, and because of that, there is a problem. So, but that issue was I was knowing from the MPW3 onward, and I taken care additional precaution around the SRAM with given a two options: launching the data on raise edge also and fall edge also. Both the features I given so that if there is a setup and hold issue, I should be covered. So because once you start launching at the opposite edge, it can't have a timing issue there. I may need to reduce the frequency. It's going to 100% it is going to work. No, it can fail because of their timing length. So those additional care I taken from MPW4 onward, just knowing that the library what they provided is not a clean. So I added an additional precaution in the design itself so that I may not able to meet at a higher frequency, but it can't fail because of the timing parameters.
So that's fixing a hold violation by clocking on the negative edge.
Yes.
Right.
So that feature
Okay.
I given in the both the side in iCache and Dcache both the place I can configure saying that don't use the falling edge to launch the data, and so there are rising edge of the data, the clock to launch the data. So that feature is helping me. I can see.
Yeah, you have the experience of many years.
Yes, I noticed the lips are not clean, and there was the discussions around that. And since I was knowing the problem, I thought better to put a precaution there.
Yeah. Yeah. We did the same thing with the SRAM on my chip that went on the same chipIgnite shuttle run. So we could offset the data by a certain number of clock ticks.
I have all the three series what I'm driving. So first one is a
Mm.
single core version, and here the main thing is apart from the single core, I have an additional two IPs. One is the AES 128-bit AES is there, and a single point FPU is there. Floating point processor is there. This space is same thing is available in the D core also, and this space is eaten up as a two additional score in the quad. Otherwise, the rest of the features are same. Main change between
Hmm.
the this thing is number of core difference and these two IPs. So here that's what I kept as enough space for the ADC. I need to plug in and
How much space do you have left?
is I think it should be able to. I think yeah, at least one square space is there. I feel it should be easily able to fit six channel ADC.
Okay. And maybe can you show us any demos of what you've got working so far?
Okay. So I had a one Arduino board. So what I done is I removed that Arduino chip and connected my Riscduino and driven that same setup.
Very nice. Did you have to make a custom breakout board for your QFN chip, or is the same pin out so you could just remove the chip and solder the new one on?
No. The problem is the chip is anyhow the sizes are different. So we may have one more version. So if we have the this line follower is also pin compatible boards are available. If we use
Hmm.
that board, then we can use direct plugin. But whatever
Nice.
the demo one had is a different sized one. It is a already the Arduino is soldered in that board, so it is a different
Hmm.
version. So whatever you're asking, like add-on card, I need to add to try that. It is a different development boards. But
Okay.
currently, whatever boards I am planning doing it, so those are exactly the pin size matches with the Arduino board. That's what currently I am cleaning up. So if that flow setup is there, then we can directly plug in the board. We just remove the Arduino board with the Riscduino board.
Nice. Have you already working on the Riscduino board?
Yes, I can show you the board slides.
Yeah. Okay. Oh, nice.
So that's what I done. It currently two boards. In one
Hmm.
board, I'm trying to reuse the whatever Caravelle given the add-on card,
Yeah.
and we try to match in the side interfaces same as Arduino, and second board is the where we are directly mounting our chip itself. Currently, I'm testing with this, and all the new results are with this.
Great. And then you can use any of the Arduino shields, like the motor drivers or whatever, just to plug straight into this.
Yes.
Excellent work. That's really great. Open source RISC-V compatible Arduino. Amazing. So, what are your next steps then? What's coming next?
Next, that's what I have currently at least three these boards I'm cleaning up, and the big problem is these chips are untested chips. So we are I'm creating one tester board so that first we check the chip working, then only go and solder it. That is the one thing we are
Hmm.
making one more board where we'll have a tester board type of board where we validate this chip. At least the basic things are working. Then only we go and solder this into the board. That is the one thing I'm trying. And also I'm trying individual add-on cards, whatever Arduino cards are there. I'm trying to add on and see how to what are the firmware back because even though it's I may make a board as same as Arduino, but to work it I need to adjust the Arduino software also some activities there. The basic
Yeah.
integration I done and those things are working, but till some firmware level cleanup is required based on the application what I'm using. So currently,
Yeah.
one by one, I'm cleaning up.
So, are you converting them to? I mean, how much work do you have to do from the C Arduino library to a RISC-V version?
So if you just, I want to give the how the Arduino typically when you log in, how it
Hmm.
looks. I can just give the how clean it will come up. I can give. So if you see, it is a typical Arduino setup. So this
Yeah.
board will look like an Arduino board, Arduino Uno, Arduino Uno. So it will be as simple how you see typically it is as a Uno, Arduino
Yeah.
Uno. This will board will look like an Arduino Uno.
Yeah.
And target is to just compile this code and burn it. It will work like the same, and user will not see as a difference.
Excellent. It's quite a big job you've set yourself. Are you? How are you feeling about that at the moment?
Yes, it's maybe the easiest part was the naming the chip as the Riscduino. I see. It looks it's a lot of effort I can see. Mapping
Brilliant.
SOC and then coming back to the firmware, integrating back to the this tool, and I think it a lot of involved work I can see it is.
Hmm. What's been the hardest thing so far about the bring up of the latest chip?
So the initial bring up is the where this some of the holds what I see hold violations what I see like a 1.6 holds. So those that's like a bit surprise for me because I think from my angle I nearly done the good timing closure in MPW 6.
Hmm.
But what I noticed is most of the chips are showing above 1.68, they are not working. So that means some design having some part of the function having a hold. So that created me more time to come back.
Great. Okay. Well, thanks so much for the update, Dinesh. Is there anything else you wanted to mention?
See, one of the things I see is the system. The system is stable. Means the silicon is working more than 24 hours, which is typically a very great indication for a system stability. Which is that too with a open source chip working for a 24-hour. I feel like it's a great achievement from the whole team, like open source tools and whatever the complete methodology. It is at least it may not be able to show a highest performance, but the silicon came out clean. At least some of the silicons are doing good. And and one more thing, what I see is what I simulated and silicon is matching, which itself also gives a very confidence saying that if you simulated it, the flow is not broken and it is going to produce a silicon which can be demonstrable. So that means that at least the basic things are not broken in the open length flow, I can say.
Great.
And one more thing, I can see some issues I see it in some advanced features, but I see those I'm able to reproduce in RTL simulation, which is also a good sign, saying that I missed verifying it, and I'm able to simulate it those case. So silicon bugs are I'm able at least I can see some of them I'm able to simulate in RTL also.
Great. Well, thanks very much for the update, Dinesh, and I look forward to talking to you again when you get MPW7.
Okay, thanks. Sir.